Other questions? Don't forget, if you have questions that come up, and they may either come to my office and see me, Perkins 314, or write me an email, landes@utk.edu. And email is the easy way. I see that pretty often. I didn't give you my phone because when I get phone messages, it takes a long time for me to get to them.
Well, since we still have some time,
Sure.
I can keep asking questions, maybe
Yeah.
with the idea that would prompt other questions. You mentioned the 2% at some point.
Yeah.
Where is that coming from?
When I design a spring like this and put everything together, one of the things that comes up is number of coils. That's important. So if the optimal design has number of coils being 8.43792, usually you don't make a spring to 8.43792, you make it either 8 or 9 or 8.5. So I often, when I get an odd number of coils coming out of my design, I just make it an even number. And then changing that number of coils to an even number to make a reasonable thing throws one of these things off a little bit. So I usually say, well, I don't hit the deflection quite right at 50, it's 49.5 or 50.5, which is okay, % off. So that's where I let that couple % come off, to try to make designs that are sort of even numbers. Not necessary. I know you all have calculators that have so many digits, more than you need, but I don't. I buy cheap calculators from wherever, $10 calculators, and do the rest with my head if I can. Yeah.
If deflection is this, pushing down,
Yeah.
what is this?
That's deflection as well. And
Is
that's
there positive, negative deflection?
Yeah, but that's another kind of spring. We have a spring called an extension spring. To obviously to go this way, you need end hooks. And when you put end hooks on so that you can pull them, you get bending stress, this and this. So it's a little bit more complicated. One of the reasons I stuck with a compression spring, but that is another kind of spring. So the 3 springs we talk about in that 466 class are compression springs. It's the model for everything. The extension springs and then the mousetrap springs, called torsional springs, which are also a little bit more complicated. So this is the simplest of the springs. And of course, as I said, without any end hooks, can only go in compression. Other things? Yeah.
Okay, so N is the number of coils, right?
Mhm.
Okay, so you didn't say anything about that in the given. So, but if you had more coils, wouldn't that make it the number of coils you have? Wouldn't that make a difference?
Yeah.
In what your diameters could be and
Yeah.
stuff?
More coils gives you more deflection for the same force, so it helps the deflection. More coils makes it buckle easier. So more coils makes it higher, LF, makes it buckle easier. So that's a limit. Then you don't want too many coils or buckles. You don't want too few coils or you can't get the deflection you need. So you have to, that has to be optimized some way. So I guess the sizes here, spring steel isn't real expensive, but you want to save money. Big operations save a few cents on each piece like this, and it's $1 million in the end, I guess. I'm not into business that much, but some people are. Yeah.
I've been trying to think about this in my head, but that little spring you gave us that had the extra coils that were together
Yeah.
on the top and bottom, if that makes it easier, that does make it easier to buckle, right? Those extra links.
Yeah.
So what are the purpose of those?
I don't know.
You don't know?
I wouldn't ever design a spring like that, but somebody gave me this. I'm a catch-all for toys. Anytime somebody has toys or broken something, they usually give it to me. Say, oh, look at this. I say, yep, it's broken. And somebody gave me this. I don't know where it came from, but in our design book, we don't have, this has four of them at each end. And the maximum we go to usually is 2. So I don't know don't know why they had that. Yeah.
Under buckling, you have the free length divided by deflection is less than or equal to 4. Is the 4,
This is diameter.
or I'm sorry, diameter.
Yeah.
Is the 4 something that is characteristic of music wire only? Or
No,
all
springs.
all springs?
Yeah, there's another way to avoid buckling, which is to fix the ends. If you put these ends in concrete so they can't twist, then they don't buckle as easy either. But this is a case where the ends aren't stuck into concrete. We're just pushing them with our finger. And this particular spring, if you analyze it, it can buckle. It's designed to buckle, or to be able to buckle. Yeah, so this is coil diameter, free length. Free length is how high it is just sitting here in my hand. Yeah.
You were talking earlier about drawing out the wire and how that makes it stronger. Is it actually more expensive to make the smaller, stronger wire than to keep a larger portion of wire?
Slightly, yeah. But cold drawing is, I don't think it's real expensive. Once you start pulling, a couple more pulls doesn't hurt. I know about that. That's what's called material science side of it. And I just know about it. I don't study material science since I'm a mechanical engineer. But yeah, that's material science. And all you engineers are going to take material science someday. So you'll learn about that. And when you learn about that, you'll know more than I do. So you'll be in better shape.
So you mentioned the difference between compression spring and extension spring.
Extension, yeah.
So there is one effect you mentioned, the torsion, and we will talk about it later. They don't know what torsion yet.
Right.
But we will talk about curvature and torsion. And you mentioned bending and torsion for the extension spring. So do you mean that bending?
Bending comes in the end hooks. Yeah. I'm not a real good artist, so forgive this, but here's an extension spring. All the way through here is torsion. Torsion is like somebody grabs your arm and twists it. Like that, that's torsion. Bending, somebody breaking it in two. Bending, I don't know if any of you are Boy Scout, Girl Scouts, or camp in the woods and make little fires. If you're going to make a little fire with some little sticks, how do you break your stick? Over your knee. Yeah, that's bending. And bending gets really high stresses. That's why when you have a stick, you don't try to pull it in half like that. You put it over your knee because you get much higher stresses and break it. Now, here, all the way through here, you're going to have bending. You can imagine you're pulling this up and trying to snap it off like a stick. So that's bending, and then the body is torsion. And all of you are going to take some mechanics and materials course. You'll learn about all these, and it will be exciting when you learn about all these things. You'll be able to put names and equations to all these things we talked about. Haven't taught that for a while, so I'm not likely that I would teach it, but I have in the past taught that. So for mechanical engineers and nuclear and others, ME 321, which you take probably sophomore year. Other things on stress, torsion, springs, failures?
Maybe the last thing, for the overall situation you're working with is pretty much static, is it?
Yeah,
So you're not talking about dynamical.
right, yeah.
So it's
That-
just-
That's fatigue. This is called fatigue loading. That's a whole nother set of equations, which we didn't bring up. That's more complicated yet, but fatigue's a good area. If you want, by the time you get to be graduate students, I teach a course in fracture that includes fatigue, so you can learn fatigue. And 466, we have a couple lessons on fatigue, real simple fatigue, but fatigue obviously is one of the number one ways of failure, fatigue. So that's important, but this is just static, right? You're pushing it and holding it wherever.
Thank you very much.
Oh, you're welcome. So